All right, this video is going to help us with our free response on our final. So we're going to use this equation right here, only I need to change that to be an x. So we have y minus x squared plus 4x minus 4 equals 0. And this says graph and label the following quadratic equation, that means this one, and answer the following questions. So the first thing it says is, what is the related function? And I put a little note to you to put this in standard form, isolate y, and make sure your leading coefficient is positive, if you can. So what we're going to do is get y all alone. So I have y minus x squared plus 4x minus 4 equals 0. So if I want to get y alone, that means I have to get rid of this term, and this term. So I'm going to add x squared to both sides. And while I'm at it, I'm going to subtract 4x from both sides. And while I'm at it, I'm going to add 4 to both sides. So what that did was it allowed me to rewrite this equation in standard form with the y isolated on one side of the equation, but I did it legally because whatever I did to one side, I did to the other side, so I didn't change the overall value of my equation. So these cancel out, these are opposites, these are opposites, and these are opposites, and I'm left with y. And then over here I have x squared minus 4x plus 4 plus 0, but I don't have to add the 0 because identity property says anything plus 0 doesn't change its identity. So even if I added 0, I would still get this. So that is what I would write down for the related function. This function is equal to this equation up here, but it's written in standard form. Now that it's in standard form, I can identify A. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 4. C is the coefficient, or actually C is the constant term, which is 4. Okay, so I put it in standard form and I've identified A, B, and C. Now this says find the roots and plot on the coordinate plane. So this says solve it anyway. Well, if I'm going to solve it, that means I'm going to find a solution. That means I'm going to find the roots. So what I'm going to do is take this equation, and if I'm going to find the roots, I have to make y equal to 0, because my roots are my x-intercepts. And whenever I'm looking for x-intercepts, the y is always going to have a value of 0. So now this is still in standard form, but now I have it set up so that I can find my x-intercepts, because my x-intercepts are also called my roots or my solutions. Now the question is, how are you going to solve this? Well, I can solve it any way I want to. It doesn't tell me how to solve it. So I've got choices. I can try to factor it. I can use the quadratic formula. I can complete the square. I could graph it, but that's not the best way to find the roots. The two ways that work the best for me, I factor it if I can, and then if I can't factor it, I'll use the quadratic formula. So let's try to factor it. Let's see, I'm going to use my menu. There's no GCF. Is this a special case? Hey, wait a minute. This is a square term, and this is a square term. And if I take half of my middle term, which would be negative 2, and square it, I would get 4. This is a special case. This is a PST. So I know that if I have a PST, I'm going to factor it and get a binomial squared. So the binomial that I would square to get this perfect square trinomial, I would take the square root of x squared, the sine of the middle term, and the square root of the last term, and that still equals 0. Now I'm going to take this and I'm going to call this, since this is x minus 2 quantity squared, that means x minus 2 times x minus 2. Now this was completely factored right here. It's still completely factored. I'm just expressing it in a little bit different way because now after it's factored we want to solve. And the way we're going to solve is to use the zero product property. So I set each factor containing a variable equal to 0. So here's one factor containing a variable and here's another factor containing a variable. If I isolate my variable, x is going to equal 2 here, and x is going to equal 2 here as well. All that means is these two roots are the same, so we have one solution. So my root, or my x-intercept, is x is 2 and y is 0. So if I'm going to graph that, I'm going to go over to my graph here, and my root is 2, 0, and I'm going to graph that or label that my root or my solution. Now it says find the axis of symmetry. Oh, by the way, my root is the point 2, 0. Sometimes we have two roots. This time we have one. Sometimes we have none at all when it doesn't touch the x-axis. Find the axis of symmetry. Well, x equals negative b over 2a. So x equals negative b. Please notice b is already negative, so I'm going to take a number that's already negative. I'm going to make it more negative, and then 2 times a would be 2 times 1. Well, negative 4 is positive 4, and 2 times 1 is 2. 4 over 2 simplifies to 2. X equals 2 is my axis of symmetry. Now I noticed something interesting. My root is on my axis of symmetry, which means my vertex is always on my axis of symmetry. So I believe this is my vertex, because if this is only going to touch the x-axis once and it's going to open up because my leading coefficient is positive, that means it's going to touch it here one time and then it's going to come up here on both sides like this. So this is not only my root, this is also my vertex, or the minimum point on my parabola. So the vertex is also 2, 0. If I plug this 2 back into my equation for my x value, I would get 2 squared is 4 times 1 is 4. Negative 4 times 2 is negative 8 plus 4. 4 minus 8 plus 4 equals 0. So when x is 2, y equals 0, there's your vertex. Find the y-intercept. Well, I know that the y-intercept is my c term. And if c is 4, then I know my y-intercept is 4. And that point right there, x is 0, it's not here, it's not here, it's right here, and y is 4. So there is my y-intercept. Okay, now I have 2 points on my graph so far. And it says, explain why you might need to find 2 more points on the same side of the axis of symmetry. Well, the reason I want more points is because the more points I have, the more accurate my graph is. With these 2 points right here, that's not really accurate at all. Is my graph going to come out like this, or is it going to come barely up like here and turn and come back up? What's it really going to look like? How wide is it going to be? One thing I can do, since I have this point here, I can go equidistant on the other side of the axis of symmetry and put another point there, because I know my parabola is symmetrical. This is the very center of my parabola. So I actually have 3 points now. I usually like to have 5, but they're asking us to find 2 more. So we can do that. Wonder why they say on the same side of the axis of symmetry. Well, if I get 2 points over here, then I can automatically graph their mirror images over here. So if I find 2 more points, I'm going to get 2 additional points as like freebies. So